Hello everyone, welcome to my channel. In today's video, we will talk about the question 4. Question 4 is about the system of equations. It's very important. Suppose that C is a real number. Solve the following system of equations for x and y in terms of C. So part A, we get these two equations. The following system of equations. And this equation is equation number 1. This equation is equation number 2. Now we have two x and y. I wanted to get rid of y first. So I times equation 1 with 3 and I use 2 times equation 2. Because I want to get 12y minus 12y, so I can get rid of y first. So let's do that. Times equation 1 by 3. It's 9x plus 12y minus times equation 2 by 2. It's 2 times 5x. It's 10x. 2 times 6y. It's 12y. And 3 times 10 is 30. 2 times c, it's minus 2c. Now this y, positive 12, negative 12, they're gone. And 9x minus 10x equals to minus 1x equals to 30 minus 2c. And we times minus 1 on both sides. So it becomes x equals to 2c minus 30. And now we substitute x in equation 1 with 2c minus 30. So the equation becomes like that. 3 times 2c minus 30 plus 4y equals to 10. And we solve this equation, we get y. 3 times 2c is 6c minus 3 times 30 is 90 plus 4y equals to 10. And we add 90 on both sides. This 19 is gone. This is 10 plus 19 is 100. And 4y equals to 100 minus 6c. Here we minus 6c on both sides. So it becomes 4y equals to 100 minus 6c. And we divide 4 on both sides. So it becomes y equals to 25. 100 divided 4 is 25 minus 6 divided 4c. And this one, I divide 2 up and down. So it becomes 3/2 c. So now y equals to 25 minus 3/2 c. In terms of c, x, y is like this. X equals to 2c minus 30. Y equals to 25 minus 3/2 c. Let's see part B. Determine all integers d for which the system of equations has a solution xy, where xy are integers. Determine all the integers d. Okay, let's see part B. Determine all integers. We have these two equation system of equation 1, equation 2. I want to get rid of x first. So equation 1 times 4 minus equation 2. It's 1x minus times 4, multiply 4 is 4x. 8y multiply 4 is of 2y. 2y multiply 4 is 8y minus 4x minus dy equals to 3 times 4, 12 minus 6, 12 minus 6. So there's no x anymore. 8y minus dy equals to 6. 8 minus d, bracket y equals to 6. So y equals to 6 over 8 minus d. 8 minus d must be a factor of 6, must be positive negative 1, positive negative 2, positive negative 3, positive negative 6. So let's see the table here. 8 minus d, if 8 minus d equals to minus 6, d equals to 14. Y is minus 1, x is 5. X equals to 5. And we do all the possible 8 minus d, and we got all the x and all the y. They are integers. So there are 8d. They are 2, 5, 6, 7, 9, 10, 11, 14. Now let's see part C. Determine a positive integer k for which there are exactly 8 integers and for which the system of equations has a solution xy where x and y are integers. Oh, these two equations. It looks complex. It looks complicated. Don't be frightened by these two equations. Let's do the same way. We get rid of x first because it's easy. Yeah. First one times 2. Second equation times 3. And we can get rid of x first. And after we do the simplification, all that, we get this equation, and 3n plus 2 equals to 0 means n equals to minus 2/3, which is not an integer, which is not an integer. So 3n plus 2 cannot be equal to 0. So y equals to minus 1. And we substitute equation 1 with y, we substitute y with minus 1, and we get this. And we get this. And we get this. And we get x equals to this. Since 3n plus 2 is 2 more than a multiple of 3, 3 is not a prime factor of 3n plus 2. So 3 times n squared plus n plus k plus 1 being a multiple of 3n plus 2 means that this one is a multiplier of 3n plus 2. So now we can get this one. We just proved that this one is an integer. We just show this one is an integer. N plus 3 plus 3k divide 3n plus 2. Similarly, This one don't have a factor of 3, so we times 3. It's also a 3n plus 2. It's also a factor of this one. And we get this is, and we get this like this. So now we prove that 7 plus 9k divided 3n plus 2 must be an integer. We're phrasing the question in these terms. We are looking for a positive integer k for which there are exactly 8 integers n, so that 3n plus 2 is a factor of 9k plus 7. This means we need a positive integer k so that exactly 8 of the factors of 9k plus 7 are 2 more than a multiple of 3. Are 2 more than a multiple of 3. Okay, we start k with 1. We have these factors. Yeah, there are 1, 2, 3, 4, 5. 5 is less than 8. No, it's not correct. And let's try k equals to 2. K equals to 2. 9k plus 7 equals to 25. And we have factors, these 6 factors. And there are only 6 factors, so it's less than 8. 2 does not work. So let's try k equals to 3. 9k plus 7 equals to 34. And we have these factors, and only these 4. Only these 4 are like 3n plus 2, are 2 more than a multiply of 3. So let's try 4, 5, 6. 4, 6, they are prime numbers. There are only 4 factors, less than 8. And we'll try 5, and we see there are only 6. It's 2 more than the multiple of 3. So until we see this, 70, there are 16 factors, and there are 8 of them satisfy the constraint. 2 more than 3n. So now we found k equals to 7. Determine a positive integer. Now we found 1. So there's no need to find anything else. N equals to 7 and 3, k equals to 7. 3n plus 2 equals to minus 17, minus 10, minus 7, minus 1, and 2, 5, 14, 35. N equals to minus 24, minus 4, minus 3, minus 1, 0, 1, 4, 11. Exactly 8. Now we solve this problem. Thank you for watching. See you next time.